Now that we know what percent composition is, we can start looking at empirical formulas. It's really important to be able to figure out an empirical formula because when you analyze a compound and want to know what it is, oftentimes you only get percent composition. We then have to take that percent composition and convert it into something that's more useful. And in the empirical formula is kind of a halfway step to figuring out what the final formula of an unknown compound is. Remember that when we're trying to figure out the identity of a compound, you can't just look at the molecules, they're too small. So we have to do this mathematically. So what is an empirical formula? Well, an empirical formula is a chemical formula that represents the lowest ratio of the elements in that compound. It's also important to note that many different compounds can have the same empirical formula. So just because you have an empirical formula doesn't mean you automatically know what the compound is that you're looking at. It just gives you a basic idea. So let's do a few examples to see what an empirical formula actually is. So we'll start with sugar, glucose, C6H12O6. And this is the actual formula, so this is called the molecular formula. So this is the actual compound. And we're going to convert this to an empirical formula. And the way we do this is we are going to divide the subscripts by the greatest common factor. So we look at the subscripts, 6, 12, and 6, and the biggest number that can go into these is 6. So I'm going to rewrite this down here. So the greatest common factor is 6, so I'm going to divide each of the subscripts by 6. And what I end up with is C1, H2, O1. And this is the empirical formula. This is simplified. And what it tells us is that in this compound, the ratio of carbon to hydrogen is 1 to 2, and the relationship between carbon and oxygen is 1 to 1, and the ratio of hydrogen to oxygen is 2 to 1. Let's try another example. Pentaphosphorus decahydride. So this is the molecular formula, and we need to convert this to an empirical formula. The greatest common factor of 5 and 10 is 5. So 5 divided by 5 is 1, so we end up with P1. 10 divided by 5 is 2, H2. So the ratio of phosphorus to hydrogen in this compound is 1 to 2. If I give you another compound, P15, H30, well, the greatest common factor of 15 and 30 is 15. So 15 divided by 15 is 1. 30 divided by 15 is 2. Now notice that we had two different compounds here, but they have the same empirical formula. And this can happen. So that's how we get from a molecular formula to an empirical formula.